Yeah, good morning, my dear students. So, part 4. So, I forgot to give in last session this formula. So, if you apply limit, directly you will get 1 power infinity form. So, how to eliminate a 1 power infinity form? That method, if you apply, you will get this answer ABC whole power 1 by 3. See, this you can remember easily also. Here A, B, C, how many constants are there? 3 constants. Multiply all those constants. Whole power 1 upon how many constants are there? 3. So by 3. So for example here, only 2 constants are there. Limit extends to 0. A power x plus B power x. A power x plus B power x divided by 2 whole power 1 by x. So here how many constants are there? A and B, 2 constants. Then what will be the answer? A into B whole power 1 by 2, because 2 constants, no? Suppose here A power x, B power x, C power x plus D power x divided by 4 whole power 1 by x is there. What is the answer? A into B into C into D whole power 1 by 4. Okay. Next to this formula, problems based on this formula. See, these are the cases. Here x is tending to what? Infinity. So then A power x tending to 0 if A is lie between 0 and 1. For example, limit extends to infinity 1 by 4 whole power x is 0. Because here A value is what? 1 by 4. 1 by 4 means 0.25, which is lie between 0 to 1. So using this as a formula, what will get the limit of this function? 0. Next, and A value, if A value 1, 1 power x is 1. So limit extends to infinity 1 is 1 only. Next, when A greater than 1, A power x is tending to infinity as extends to infinity. Example, your base is what? 3. A value is what? 3 more than 1. So when extends to infinity, 3 power x is also tending to what? Infinity. Next, based upon this formula problem, so if you apply limit directly, you will get infinity by infinity form. But here in this problem, we can't apply last plus rule, because here exponent is a function and base is a constant. When base is a constant, exponent is a function, and x is approaching to infinity. And if you apply limit, you are getting infinity by infinity form. Last plus rule doesn't work when base is constant and exponent is a function. That means exponential functions. Exponential functions are there. Then we can't use Last plus rule here for this problem. Okay. So then how to evaluate? So first you split like this, 3 power x terms, 5 power x terms separately. So when x tending to infinity, 3 power x tending to infinity, 5 power x also tending to infinity, because both 3 and 5 greater than 1. But which is tending to infinity fast when compared to 3 power x? 5 power x is tending to infinity fast. So that means this 5 power x infinity value is more. So whichever is more infinity, you divide with that infinity. Here 5 power x value is more than 3 power x. Of course both are tending to infinity, but 5 power x is tending to infinity fastly when compared to 3 power x. So here which infinity is more? 5 power x infinity value is more when compared to 3 power x. So divide with 5 power x throughout the equation. Sorry, both numerator and denominator. Both numerator and denominator divide with 5 power x. Then what you will get? Limit extends to infinity. So 3 into 3 power x by 5 power x can also be written as 3 by 5 whole power x plus 2 into 5 square. 5 power x get cancelled. And here 4 by 3 into 3 power x by 5 power x can be written as 3 by 5 whole power x minus, after dividing with 5 power x, what do you get? What is the remaining? 3 into 5. Now take observe, be carefully here. 3 by 5 is nothing but 0.6, which is less than 1. It is also in the form of a power x, a value 3 by 5 and a value less than 1. When extends to infinity, that a power x is what? Tending to 0. So here 3 by 5 whole power x tending to 0 when x tends to infinity. So that's what you'll get, 3 into 0 plus 2 into 5 square divided by 4 by 3 into 0 minus 3 into 5. So that's what you'll get, 2 into 5 square numerator, denominator minus 3 into 5. So 155 get cancelled. What you'll get, 10 upon minus 3, which is equal to minus 10 by 3. So for this kind of problem, I give shortcut like this. So here, which power is more? 3 power is more, 5 power is more. So 5 power is more. Then you neglect 3 power x terms. Then you just simplify matter. 5 power x plus 2 by 5 power x plus 1, what will you get? 5. So 2 into 5 by minus 3, minus 10 by 3. Over. Here 5 power x value is more now, when compared to 3 power x. Then the terms which contains 3 power x you neglect. Remove. And here first you simplify and apply x tends to infinity. So 5 power x plus 2, 2 by minus 3, minus 2 by 3. Okay. Then 5 power x plus 2 by 5 power x plus 1, what will you get? 5. So minus 2 by 3 into 5, minus 10 by 3. So to understand this, again one more problem, I am giving one more problem, one more example. So limit x tends to infinity, 2 power x minus 3 power x, or plus you take 4 into 3 power x divided by 2 power x minus 1 plus 5 into 3 power x. Here you take x plus 2. Then what you need to get answer here, x tends to infinity, 2 power x, 3 power x, both are tending to infinity only. But which power is more, sir? Which among these two infinities, which infinity is more? 3 power x infinity is more. Okay, so 3 power x value is more than 2 power x. So that means you can neglect these terms. Then what is left? 4 into 3 power x plus 2 by 5 into 3 power x. Limit x tends to infinity. So 3 power x get cancelled. Then what is the remaining? 4 into 3 square. 4 into 9. 36 divided by 5. That was answer. Now you apply procedure. Divide numerator and denominator by 3 power x. So 2 by 3 whole power x is tending to 0 because 2 by 3 is less than 1. Between 0 to 1. Next next problem. So limit x tends to infinity. Limit x tends to infinity. 2 power x plus 3 power x plus 5 power x whole power 1 by x. So if you apply limit directly, 2 power infinity, infinity plus infinity power 0. So infinity power 0, what is the method there? So what is the method? E power limit x tends to a, g of x into log f of x. Don't apply that method here, because here f of x is what? Exponential function. So that method does not work. Okay. Then how to evaluate this? So same logic, among these three, 2 power x, 3 power x, 5 power x, which is more? 5 power x is more. So multiply divided with 5 power x. Or you take 5 power x common. So limit x tends to infinity. You take 5 power x common. Then what you will get? 2 power x by 5 power x, 3 power x by 5 power x plus 1 whole power 1 by x. So that is equal to limit x tends to infinity using a into b whole power m, a power m into b power m, that is 5 power x whole power 1 by x into 2 power x by 5 power x is 2 by 5 whole power x plus 3 by 5 whole power x plus 1 whole power 1 by x. Now here x and x get cancelled. Now apply the limit. So this 5 I am writing as it is, applying the limit. So here 2 by 5, 3 by 5 both are like between 0 to 1. So both are look like a power x. So using first case of the formula, limit x tends to infinity, a power x is 0 when a lie between 0 to 1. Here a 0.4, here a 0.6. Both cases it is lie between 0 to 1. So that means these two are tending to what? 0. So what do you get? 0 plus 1 whole power 1 by x is 0 because x tending to infinity now. So thus what you got the answer? 5. Now by looking this problem, so can you say what will be the answer for this question? Limit x tends to infinity, 3 power x plus 5 power x plus 8 power x whole power 1 by x. Yes, that was correct. Answer is 8. Because here observe basis 2, 3, 5. Among those three numbers, which is the more? 5 is more. So answer what you got? 5. Here 3, 5. Basis 3, 5, 8. Among these three, which is the base? Which base is highest? 8. So answer is 8. With the same procedure, you will get the answer is 8. So one more next level problem, but same model problem. Limit x tends to 0. 1 power 1 by sine square x. 1 by sine square x is nothing but what? Cosecant square x. So they may give 1 power cosecant square x also. Plus 2 power 1 by sine square x. Next plus 3 power 1 by sine square x and so on. N power 1 by sine square x whole power sine square x. So for this problem also we can apply this formula. But it is indirectly is given. So you have to understand where. Okay. So I am going to convert this problem also in that form. Obviously you will come to know what is the answer. Okay. So I am taking, let sine square x is equal to 1 by sine square x is equal to y. Let 1 by sine square x is equal to y. Then obviously this y is tending to infinity as x tends to 0. Because when x tending to 0, sin x tending to 0, sin square x also tending to 0, 1 by 0 tending to infinity. Okay. So thus the problem is reduced to limit as x tends to 0 same as y tends to infinity. I am going to convert function of x to function of y. Okay. So 1 power y plus 2 power y plus 3 power y plus and so on plus n power y whole power sin square x. 1 by sin square x is y means sin square x is now nothing but what? 1 by y. So this problem is look like this problem only na. So here what are the bases? 1, 2, 3 and so on n. Among these bases which base is highest? N. So that was the answer. Next, using expansions. Problems using expansions. So you are familiar with the e power x expansion. What is e power x expansion? 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on infinite terms. So for any function which is differentiable continuously, for any function f of x, if it is differentiable continuously, we can find its series because every differentiable function, continuously differentiable function is approximately equal to some polynomial function. Okay, then how to find that polynomial? So how to find that polynomial? So you remember just one series, it is called Taylor's series. Just you remember this series, Taylor's series. So if f of x is continuously differentiable, then f of x can be written as f of x is equal to f of 0 plus f dash of 0 into x by 1 factorial plus f double dash of 0 into x square by 2 factorial plus f triple dash 0 into x cube by 3 factorial and so on infinite terms. Here what is f dash? First derivative, f double dash second derivative, f triple dash third order derivative. F dash of 0 means find f dash x, put x is equal to 0. F of 0 means in f of x only put x is equal to 0. F double dash 0, how we will get? In f double dash x put x is equal to 0. Okay, how we will get f triple dash 0? Put x is equal to 0 in f triple dash x. So here if I take f of x is equal to e power x, and we know that f dash x, f double dash x, f triple dash x all are equal to e power x, then automatically f of 0 is same as f dash of 0, f dash of 0 is same as f double dash of 0, and all are equal to what? 1. Now if you substitute there, what you will get? E power x is equal to f of 0, 1, f dash 0, 1 into x by 1 factorial, f double dash 0 again 1, x square by 2 factorial, next f triple dash 0 again 1, x cube by 3 factorial, and so on. Even if you want, you can put x, f of x value sin x, because sin x is also continuously differentiable. Okay, so sin x is equal to f of 0 means sin 0. Sin 0 is what? 0. Next, f dash 0. So f of x sin x means f dash x, what you will get? Cos x. Cos 0, 1. So 1 into x by 1 factorial. Next, if f of x is sin x, f dash x is cos x, f double dash x is minus sin x. So f double dash 0, what you will get? Minus sin 0, 0. So 0 into anything, 0. Next, f double dash, what you got? Minus sin x. F triple dash, what you will get? Minus cos x. So f triple dash of 0 means minus cos 0. Minus cos 0 is minus 1. Minus 1 into x cube by 3 factorial. So similarly, next term again will get 0. Next term will get x power 5 by 5 factorial, and so on. So that's sin x is equal to what? X by 1 factorial minus x cube by 3 factorial plus x power 5 by 5 factorial, and so on. So if you are unable to remember those expansions, but try to by heart all expansions: e power x, e power minus x, sin x, cos x, tan x, and log 1 plus x, log 1 minus x expansions. Try to by heart, and 1 plus x whole power 1 by x. Try to by heart. If you can't, so remember this Taylor series. But 1 plus x whole power 1 by x, that is using binomial theorem, we are expanding. So for that you don't use this. Okay. So next problem, using this expansions, limit extends to 0, e power x minus e power minus x minus 2x divided by x minus sin x. So here if you apply limit, you are getting 0 by 0 form. 0 by 0 form. Then how to evaluate? Using Elastic's rule. So here to eliminate this 0 by 0 form, we have to differentiate at most 3 times. Because x minus sin x 0. Differentiate 1 minus cos x 0. 1 minus cos x derivative sin x 0. Again sin x derivative cos x non-zero. That means 3 times you have to differentiate it. If it is easy to differentiate both numerator and denominator, you can apply Elastic's rule also, no problem. But for this problem, it is easy to apply Elastic's rule instead of using these expansions. Okay. But here anyway we are discussing expansions. Now you can use expansions also. So e power x expansion. E power x expansion, what will you get? E power x expansion, what will you get? 1 plus x by 1 factorial. I think better you apply Elastic's rule instead of using expansions. Okay, but I am explaining using expansions. Okay, because we are discussing this problem in expansion case. Okay, minus 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial, and so on, minus 2x divided by x minus sin x expansion, x minus x cube by 3 factorial plus x power 5 by 5 factorial, and so on. See here, plus 1 minus 1 get cancelled, x minus of minus x, 2x minus 2x get cancelled, and x square plus x square minus x square get cancelled. Then what you are getting? 2 times of x cube by 3 factorial. Next you will get 2 times of x power 5 by 5 factorial, and so on. Here x get cancelled. What you are getting? Denominator x cube by 3 factorial minus x power 5 by 5 factorial, and so on. So in both numerator and denominator, you take x cube by 3 factorial common and cancel, then apply limit x tends to 0. So after taking x cube common, x cube by 3 factorial common, then here x square term will left now. So x value tending to 0, then all these remaining terms become a 0. Divided by, after taking x cube by 3 factorial common, here 1 is left, here some x square term is left. As x tends to 0, x square is also 0, so remaining terms become a 0. So thus the answer is 2. Or better, for this problem you apply L'Hospital's rule 3 times. Next. So try these problems, either use L'Hospital's rule or else expansion method. Limit x tends to 0, x minus sin x by sin of x cube. Next problem, limit x tends to 0, x minus tan inverse of x divided by x cube. Next model. And also remember this formula, limit x tends to 0, 1 plus x whole power 1 by x minus e divided by x. In some books it is given e by 2, but the answer is minus e by 2 is correct. Minus e by 2 is correct. Next, in limits only, problems based on sequences, and I am going to solve one more problem based on this what we call expansions. For example, it is given like this: a limit x tends to 0, sin x minus x cube by sin x minus x plus x cube by 6 divided by x power 5. So how many times you have to differentiate? At most 5 times you have to differentiate. So if you are able to differentiate 5 times easily, you can differentiate. But for this problem I am suggesting take expansion, use expansions. Okay. So if you use expansions, what will you get? Limit x tends to 0, sin x expansion is what? X minus x cube by 3 factorial plus x power 5 by 5 factorial, and so on, minus x plus x cube by 6 divided by x power 5. So here within one step you got answer. X get cancelled, x cube by 6 get cancelled. And here next term what you will get? X power 7 by 7 factorial. That means in the numerator and denominator, if you take x power 5 common, then what you will get? 1 by 5 factorial, next minus x square into something divided by x power 5 will get. Next, because next term you will get x power 7 by 7 factorial. After taking x power 5 common, what you will get? X square. Next to x power 9. So that means what you will get? X power 4. That means in the rest of term, other than first term, after taking x power 5 common, in the remaining terms again you can take x square common. Okay. So x power 5 get cancelled. Apply the limit. So this value become what? 0, because it's tending to 0. So what is the answer? 1 upon 5 factorial is the answer. 1 upon 5 factorial is 5 factorial value is what? 120. So answer is 1 by 120. And you try this problem also. So limit x tends to 0, cos x minus 1 plus x square by 2 factorial divided by x power 4. Try this problem. just use cos x expansion. Okay. So next problem. So problem based on a sequence. So it is given that n plus 1th term of the sequence a n plus 1, it is given 2 times of 2 by a n plus a n, and it is given that all the terms are positive in that sequence. Okay, it is given that n plus 1th term of the sequence given like this, and also given that all in that sequence all terms are positive. Then we have to find limit n tends to infinity a n. Okay, so listen, whenever n tends to infinity, n plus 1 also what, tending to infinity only, correct? Suppose if I assume limit n tends to infinity a n is equal to L, then automatically limit n tends to infinity a suffix n plus 1 also what you will get? L only, no? Here a infinity, here also a infinity, infinite term. Okay, if I assume this is L, then this is also L. And according to the question, we have to find L value. And according to the question, L must be positive. Okay. So applying limit n tends to infinity on both sides of the given condition. Okay. So limit n tends to infinity a n plus 1 is equal to 2 times of limit n tends to infinity 2 by a n plus a n. Okay. So limit n tends to infinity a n plus 1 value is what? L. So 2 times limit n tends to infinity a n value is what? L, plus limit n tends to infinity a n value is what? L. So L is equal to 2 into 2 by L, 4 by L, 2 into L, 2L. So this implies that, of course, here something is gone. Oh, I think it is minus. You take minus now. Yeah, it is minus. Entering wrong, a n plus 1 term is here minus. Okay. So minus 2L, if we transfer this side, what do you get? 3L is equal to 4 by L. So 3L square is equal to what you will get? 4. Then root 3L is equal to what you will get? 2. So that's L is equal to 2 by root 3. But what is L? Limit n tends to infinity a n. That is what we need to find. The answer is 2 by root 3. Okay. Because n tends to infinity, n plus 1 also tending to infinity. If I assume this value limit of n tends to infinity as a limit n tends to infinity a n value is L, then limit n tends to infinity a n plus 1 value also L. So with this I am closing limits topic. Thank you.